Hi guys and welcome to Mini Money Masterminds. Yeah, I know. I haven't been releasing videos for quite some time. But don't worry because today I'm gonna explain you another concept. Now, first of all, you must be asking, Mahira, what happened? Because at first I released a statistics series incomplete and then jumped to accountancy. Well, don't worry, because statistics is here to be completed. Okay, now that we've got it that statistics is gonna be completed, what's our next concept? Well, our next concept to be discussed is the measures of central tendency. Measures of central tendency. What's the meaning of that? Well, measures of central tendency. Here first we talk about measures. What does measure mean? Measure is the act of quantifying something, right? Measurement or measuring is the act of quantification of any item. But, here we're using measure as a noun. So when we're using measure as a noun, it means any tool used for quantification of the central tendency. So central tendency is the inclination of any event to happen or occur. The main inclination, like when, in what situations does an event occur most frequently? Alright? Now, measures of central tendency. Let's learn the types of measures of central tendency. You might say, oh, that's mean, median, mode. But it isn't all that easy. Measures of central tendency is broken down to the mathematical averages and positional averages. Mathematical averages contain the arithmetic mean, geometric mean, and harmonic mean. We'll be learning arithmetic mean just for your information. In the positional averages, there is the median, the partition values, and the mode, and we'll be learning all three of them. So now, what are you waiting for? Let's begin as we dive into this deep and interesting concept.
So yeah, mean, median, and mode. Let's start by understanding the definitions of each of these. Well, mean is a number that can be used to represent an entire bunch of data. Right. And median is the middle number when the data is arranged in an ascending order. In case there are two numbers in the middle, we take out their mean. And mode is the most commonly occurring number. Right, so mean is a number that can be used to represent an entire bunch of data. Median is the middle number when the data is arranged in ascending order. In case there are two numbers in the middle, we take out their mean, and that is the median. Mode is the most commonly occurring number. Righto. So first, let's see the concepts in the arithmetic mean. Now, don't forget that there's arithmetic mean, geometric mean, and harmonic mean, but this time we'll only learn arithmetic mean. So here are the contents one by one. Simple arithmetic mean, ungrouped data, three kinds of methods for ungrouped data. Then there's grouped data, three kinds of methods for that too. Frequency distribution, cumulative frequency distribution, mid-value series, and inclusive series. But that's not the end. Weighted arithmetic mean, combined arithmetic mean, corrected arithmetic mean, and an additional topic, location of missing item or frequency. Well, what is simple arithmetic mean? Simple arithmetic mean, well, that is just what's not weighted arithmetic mean. It's basically where there are no weights or importances and all values are of equal importance. Now let me remind you that ungrouped data means individual series. Now an individual series is the one where raw data is spread out, remember? Right, so the direct method for getting the simple arithmetic mean in ungrouped data has the formula. Now look, just the mean, the arithmetic mean is represented with an x, okay, which has a bar on top. Now the arithmetic mean equals to the sum of all values divided by the number of quantities. Remember that x stands for the number of all the values, okay? The sum of all values divided by number of quantities equals the arithmetic mean. Now the assumed mean method. So let's now focus on the formula and get to know what's the assumed mean. Well, assumed mean equals to the maximum value plus the minimum value divided by 2. Righto. So arithmetic mean, according to this method, equals to the assumed mean, which is the maximum value plus the minimum value divided by 2, plus the sum of all deviations divided by number of quantities. Well, what is a deviation? It's just the difference between, a value, all the values, and the assumed mean. This, like, there's a separate deviation for every value. And sometimes this can come out as negative, And then there's step deviation method. Well, in step deviation method, the arithmetic mean equals to the assumed mean plus. Now, assumed mean is the same. It's maximum value plus the minimum value divided by 2. So, arithmetic mean equals to the assumed mean plus the sum of all deviations apostrophe. Now, deviations apostrophe. Well, first, what is deviation? It's x minus a, right? When we get all the deviations, there will be some common factor. Maybe the common factor is just 1 or 2, but there will be a common factor. Sometimes it's 1. That's sometimes, not every time. So over here, what we do is that the common factor of all the deviations is c. You can see that? And now the d apostrophe is actually x minus a, like the deviations divided by c, which is the common factor. Right. So arithmetic mean equals to assumed mean plus sum of all deviations apostrophe divided by number of quantities multiplied by common factor. Right. Now group the data. Group the data is a discrete series or a frequency array. Now in the direct method is the arithmetic mean equals to, well, we see that some things have changed. Well, first of all, let me tell you, when you stumble upon things like this, we just divide it from here. Yep. Actually, here the formula says is that arithmetic mean equals to the sum of all frequencies multiplied by values divided by the sum of all frequencies. Yep, that's easy to remember. So, that's the direct method. But what about the assumed mean method? Well, in the assumed mean method, assumed mean equals to the maximum value plus the minimum value divided by 2, obviously, and the deviation for each value equals to the value minus the assumed mean. So here we say that the arithmetic mean equals to the assumed mean plus the sum of all frequencies multiplied by deviations divided by sum of all frequencies. In the step deviation method, this is a little indent. Here we do assumed mean, which I just explained, plus. Now again, we divide it over here. My apologies. So over here, the assumed mean plus, as I told you many times, this will occur that you're confused, but nothing to be confused about. So assumed mean plus the sum of all frequencies multiplied by deviation apostrophes. Now, same thing is applied over here. The deviation apostrophe equals to the value minus the assumed mean divided by the common factor. Now, common factor, don't forget, this is the common factor of deviations. Okay, so assumed arithmetic mean equals to the assumed mean plus the sum of all the frequency multiplied by deviation apostrophes divided by the sum of all frequencies multiplied by the common factor. Now, we've discussed group data, but what about the frequency distribution? Yeah, in the direct method, what happens is that formula is the arithmetic mean equals to the sum, well, forget this, sum of what? We can't include classes over here, right? So we first will need to take out the mid value. Every time we first have to take out the mid value, or M for short. Well, M or mid value, we got that right. So arithmetic mean equals to the sum, well, the sum of all frequencies multiplied by mid values divided by the sum of all frequencies. Now the assumed mean method, well, here the assumed mean is calculated a little differently, where the maximum mid value plus the minimum mid value divided by 2 equals the assumed mean. And the deviation equals the mid value minus assumed mean. This can sometimes come negative, as already told. Now, coming back over here, we can see that the arithmetic mean equals to the assumed mean plus the sum of all frequencies multiplied by deviations divided by sum of all frequencies. Okay, that's pretty much easier. And now, in the step deviation method, well, the arithmetic mean equals the assumed mean, as explained earlier, plus, well, over here the D apostrophe is equal to the mid value minus A divided by common factor of all the deviations. So, it's assumed mean plus the sum of all frequencies multiplied by deviation apostrophes divided by sum of frequencies multiplied by common factors. Okay, so once again we've understood frequency distribution, but what about cumulative frequency distribution? Well, we just converted into a frequency, a normal frequency distribution, and solved it. In the mid-value series, we follow the steps of the formula of a frequency distribution except the conversion of the classes to their mid-values, as they are already converted. And in an inclusive series, we convert it into its mid-values and solve it. Now, simple arithmetic mean is discussed, so weighted arithmetic mean. Well, here we have weights that tell the importance of every value while calculating arithmetic mean. Okay? So, the weighted arithmetic mean equals to the sum of all weights multiplied by values divided by the sum of all weights. Right, that is quite easy to understand. Now, after that, there's combined arithmetic mean. What is the combined arithmetic mean? When we have two or more parts of a series and need to take out the mean of all the parts, yeah, that's the combined arithmetic mean. Well, actually here we have two or more parts of a series and we want to take out the mean of the entire series, not of the two or more parts, because right now we're focusing on the arithmetic mean of an entire series, right guys? So over here the combined arithmetic mean equals to the arithmetic mean of the first part multiplied by the number of quantities of the first part plus, and on it goes till the arithmetic mean of the last part multiplied by the number of quantities of the last part. Oh, and by the way, divided by number of quantities of the first part and on till the number of quantities of the last part. Okay, now corrected arithmetic mean is used if a value in our formula was put in wrong. We can fix that quite easily with the corrected arithmetic mean. So the corrected arithmetic mean equals to the sum of the wrong values, okay, or the wrong value and the correct values, because sometimes what happens, only one value is wrong, right? So the sum of values, which was wrong, plus the correct value minus the incorrect value divided by the number of quantities. And now, if we have to locate missing items or frequencies, we can find it out easily. In an individual series, we can see that these are relationships, but when we know that the arithmetic mean equals to the sum of all the all the values divided by the number of quantities, we can easily figure out the rest, right? So over here, if you're a student class of 11th, it's very easy to understand, exchanging places in algebra. So that's pretty much it. When you put this x over here, like you put this x with a bar on top over here, and put the sum of all quantities over here, we know that the arithmetic mean multiplied by the number of quantities equals to the sum of all the values. And like that, the number of quantities equals to the sum of all values divided by the arithmetic mean. Now in a discrete or continuous series, well, it's basically this formula and we just exchange the places. Same. Well, using these different formulas, we can find out if any frequency is missing. So don't forget that you'll need to practice questions based on every kind of arithmetic mean, not even arithmetic mean, all the other types of measures of central tendency. So, yeah. Now, phew, keep watching. I'm just gonna go and relax for a while. Let's hope it's not been long enough, and yeah, let's go to meet. One sec. Yeah, the median, well, you can check out the contents, and let's move on. Now, for ungrouped data, we follow this if there are an odd number of items. Now, the n plus 1 divided by 2, and that's the position of that item. If there are even number of items, we find out the arithmetic mean of the middle two numbers. And this is for an individual series, okay? Don't forget that if there are an odd number of items, we first arrange them in ascending order. Now, median calculation for grouped data. This is the discrete series, okay? So first of all, the discrete series frequency is converted into a cumulative frequency distributions frequency. So we got a cumulative frequency too, okay? Along with the discrete frequency. Now the sum of all the frequencies is treated with this formula, meaning the last cumulative frequency plus 1 divided by 2. That item is technically considered. But what if that frequency isn't even given in the cumulative frequency? Well, the cumulative frequency equal to the answer, For example, if the sum of all frequencies is 60, so if it's 61, then 62 divided by 2. Well, 62 divided by 2 equals 31. So the 31st item will actually be the answer, okay? But now what if there isn't a cumulative frequency equal to 31? Well, if there isn't a cumulative frequency equal to 31, the greater one out of the two surrounding it has its x as the median. Well, first of all, 31 will be positioned between two cumulative frequencies. Let's say one is of 28 and the other is of 40. So the greater one, right? So the greater one is 40. So 40's value is the median, okay? The x of 40 is the median. A quick note is that for grouped data and for frequency distribution, in case the sum of all frequencies is even, we don't need to do this part, okay? Only if the sum of all frequencies is even. Now over here, we convert the frequency into a cumulative frequency, and then we apply this formula. Okay, that's a little bit. But total frequency plus 1 divided by 2, like here, same thing we do. And then, now look, it's not all the same. Now let's say I got 31 here too. Now, let's say 40, right? 40, 40 is actually the greater one out of the two surrounding 31, right? Now, 40's class is called the median class. Now, L1 is the lower limit of the median class. Get it? Just understand slowly, and continuously rewash the part which you're not understanding. So here what we're saying is that the cumulative frequency, equals to 31, which is now 31. What was 31 again? 61 plus 1 divided by 2, right? So 31 was not present. The greater one out of the two surrounding it was 40. So 40's class is the median class. Now the median class has a lower limit, remember? So the lower limit is L1. We apply every part of the formula and then just solve it. Plus, well, N obviously is the number of values or classes, okay? And CF is the cumulative frequency. Remember this part of the class preceding the median class, okay? So the cumulative frequency of the class preceding the median class is CF, right? And F is the frequency of the median class. And I is the size of the median class interval. Now you can see that if you apply each of those things over here on this equation, well, you can solve it and get the median. Now for a cumulative frequency distribution, we convert it into a continuous series but keep the cumulative frequency and solve it with the same method. And for an inclusive series, we convert the inclusive series to an exclusive series, as I had explained in one of my videos in the statistics playlist. And then we solve it by entirely the same formula. Now, what if there's unequal class intervals? We'll convert those unequal to equal class intervals and use once again the same formula and the same steps. We just need to fit them in, from unequal to equal, or from inclusive to exclusive, or from cumulative to continuous. Yeah. So now locating missing frequency with the help of a median. Well, okay, we've got a big thing in our hands, so we gotta listen very carefully. I mean, you gotta listen very carefully. Now what's the thing is that over here we've got this, okay? Now n is equal to 100. I noted it down for you to understand. And over here, well, we can see that if n equals to 100, that means these two things will equal to 25. So we will know that f, because 75 is already given, remember? So f1 plus f2 is 25. Okay? Now, if this is equal to 25, what else do we do? Now, I can't note down everything and waste our time, okay? This valuable time we've got. So we know this much, okay? And I will note down the major points over here. So now we know that the median is 30. So we write down the equation. N is equal to L1, like the entire this. We note down this entire equation, okay? Properly on a notebook. So after that, once we've noted it down, what do we do is, now don't forget, okay? Don't forget that there's actually separate, okay? This is actually separate. You gotta follow the rule of BODMAS to actually get the answer. So this equation we'll note down, and then we will write in the place of L1, okay, we'll write 30. One sec. I shouldn't probably be writing here, so erase all incomes. So remember that first you gotta note down this formula, okay? Now go over here. We will note down this very same formula. Oops. So first of all, we need to remember that F1 plus F2 equals to 25. Now once we've known that, what we need to do is that we need to figure out F1 and F2 separately, right? Okay, so what happens is that over here, we will write down the entire, we're not going to write down the equation, we're going to write the full equation. Oh, sorry. Now we take pen. So we'll write 30, which is median, equals to, well, 30 equals to, oh, my apologies. So 30 equals to, what does it equal to? Now, lower limit of the median class. So lower limit of the median class. Now, how do we know the lower limit of the median class? You know, lower limit of the median class, well, it's 30. How do I even know it's 30? Because, look, from looking at this entire thing, we're just gonna, one sec, okay? Right, so what we did was that we assumed that the n was 30, right? Oh, the n was 30, so over here the lower limit is 30. Oh, great, that's the thing I don't want to go writing in a flat. So 30. So 30 equals to. Now we have to solve this a little slowly instead of. Okay, we've got the L lower limit, okay? Then what's there? Plus, okay? Now, what's there after the plus? We'll have to get the n. N is already with us, right? So 30 plus, okay, now plus, now 30 plus n. No, let's actually speed it up a little because I'll not waste time by writing brackets and everything too. So n upon 2, which is 100 divided by 2, it's equal to 50 minus CF. Well, over here, cumulative frequency is equal to 35 plus F1. Great. So what we need to do here is, that is very interesting. Well, obviously, what we're going to do is that 30 plus 50 minus, okay? Just think of it as 50 and not 3, okay? 50 minus. Now 50 minus, obviously, now this will come in brackets. Don't forget this. This will obviously come in brackets. 50 minus, this is the upper part of that division we're doing. 50 minus 35 plus F1. Okay, and now that we've done that, okay, F1, right, upon, now this is upon, okay, upon 30, multiplied by 10. Now that's actually I. Remember what does I stand for? Gone. If you've forgotten, then I is the size of the median class interval. Here it's equal to 10, remember? So, multiplied by 10. Okay, now what do we understand from here? Taking the eraser, what we do is that we erase this part a little bit and solve it even further. What we're trying to say is, well, what was previously here? That was 50 minus 35 plus 1. What we simply did was that, what we did was that we cut this, and we cut this, and this. What remained was, now what we did, 50 minus 35 plus F1 was converted to 15 minus F1. Wait, how did that happen? Okay, let's rewind a little bit. What we just did, okay, we just, cut them off without any explanation. But now let me explain step by step of what I did. In the writing it once again, we know that what we have written was 50. Okay, you don't forget to write this on your own textbook or notebook, whatever. Okay. So actually, it's my cue for explaining what I did. Now look, what we have here, now it's actually dividing something by 30 and multiplying it by 10. Once again, so now don't you take that multiplying by 10 and 30, well, it technically ends up with divided by 3, right? And then over here, if we remove this 30 and this 30, this means that 50 minus 35 plus F1 divided by 3 equals 0. Right, so technically, one second. From what we've got up till now, we have technically reduced this to the simplest terms we could. But we can still reduce it even further. Well, how's that? Well, if we break these brackets, what will happen is that we will convert this. Oh, now I guess I'll need the eraser. Now I'll tell you what I did. When we will break the brackets and these big numbers come into view, they're not that big to be honest, then what will happen is that 15 minus F1, okay, minus F1 equals, divided by 30, divided by 3. 15 minus F1 divided by 3 equals 0. That means that F1 is 25. I mean, F1 is 15. 15 minus 15, yep. 15 minus 15 divided by 3 is technically equal to 0, because 15 minus 15 is equal to 0. Divided by 3 is equal to 0 is equal to 0. Okay? And if this is equal to 15, we know that F2 is equal to 10. Yeah, that's much of it. 10. Now that we've got this, we know how to locate missing frequency. I know it took lots of time, but we understood the concept. Now, in graphical representation of the median, when you draw a less than and more than ogive with the same data, the point where they both meet is the median. To know more about the ogives, visit this link where I explain all about it. Now, what is partition balance? Now, dividing 100 can be easily done in many ways. Divided into 4 parts of 25 each, called quartiles, divided into 10 parts of 10 each, called deciles, and divided into 100 parts of 1 each, called percentiles. You got the basic part. Now, quartile. Let's learn the quick formulas of each of these. Well, look, why did I have to write 1 multiplied by? Okay, well, you see, over here, I had to write 1 multiplied by because if you wanted to know quartile 3, or the third quartile, you could have done it over here by 3. Okay, I'm just giving it for example. Don't think it means that the back part as well. Q3 is equal to the size of 3 multiplied by this very same formula. Same is applicable over here and on the percentiles. Do not think, again I speak, do not think that I had written wrong. It is just an alternate example that I'm writing upon. So, now this is for individual and discrete series. What about frequency distribution? Well, over and over again, I'll tell you that in a frequency distribution, quartile 1 equals to L1, which is a lower limit. Now, remember, over here in this explanation, what does L1 mean? Like, obviously, we're not going to calculate the median here, are we? Are we not? Well, L1 over here actually means, oops, 1 sec. So now, yeah, I might have missed a couple of points. In the frequency distribution, what we do is that Q1, for example, in a frequency distribution is equal to N upon 4. Okay, now whatever comes out as the result, okay, don't forget that first of all, we'll have to convert. Getting any understanding to where I'm going with this? CF. Cumulative frequency? Yes, cumulative frequency. You guessed right. We first have to convert the frequencies into cumulative frequencies. And then we will n divide by 4, okay? This is for Q1 only. Now, as I had told you earlier, let's rewind to that part. The best thing is that you can actually go back and forth. Yeah. The cumulative frequency equal to it, or if it is not present, the greater one out of the 2 surrounding it has its class as a median class. Well, same goes here. The cumulative frequency equal to it, or if not present, then the greater one out of the 2 surrounding it has its class as the quartile class. Okay? So once we figured out that part, then for example, we have the quartile class's cumulative frequency. Okay? Now, once we've got that part, then we can apply all of that. The lower limit of the quartile class plus the number of quantities divided by 4 minus the cumulative frequency of the preceding class divided by the f frequency multiplied by I. Oh, this was actually small I. Don't forget that. Okay, small I. So, actually I got one idea. So yeah, now that we've understood that, now I don't forget what was the I. Remember that the I, can you guess what's the I? Let's check how much you remember. Well, as explained in the earlier concepts as well, like the median and others, the I is equal to the size of the quartile class interval. So yeah, and now that we've understood that, what I'm going to do is a tiny trick so that you don't get confused that this, oh, bad. Over here you can see my white dot blinking if your eyes are shut. Yep, that's an eye, a tiny eye. Okay, and the same goes on for here. And the same goes on for here. Yeah. Okay, and the same kind of, same kind of formulae are used for the different types of percentile, quartile, and decile. So over here, you don't need to forget that this is actually 1 multiplied by, okay? Same over here, 1 multiplied. And this can turn to 3 if this becomes 3, then this becomes 3. Don't forget that these are proportional to each other. They're related. If this one is 3, so over here, these two things are related. And don't forget that this is the P one, okay? Yeah, so I hope that's clear. And I hope now that we've understood partition values, let's move on to the mode. Well, that's a lot of mess, but this has most of the things we want. Now, mode is the most commonly occurring value. So by inspection, you inspect and see the most common value in an individual series. And if you convert that individual series into a discrete series, you convert, and mode is the one with the highest frequency. Now in grouped data, the inspection method says the value with the highest frequency is the mode, and the grouping method is detailed. Don't worry. Let's go to. So in the grouping method of the discrete series, we create 2 tables. One is called the grouping table, where the discrete series is plotted down at the leftmost corner. Remember, the discrete series is plotted down at the leftmost corner, and 5 more columns are made. In the first one, we add the first and second frequencies. Wait, what? Yes. Let's say there are 8 frequencies, right? So if there are 8 frequencies, what we're going to do is that, well, see, technically, there are gonna be 6 columns, 1 of the frequencies, and the other 5 are the ones we added. So in the first column, there are the frequencies, right? And what if there are 8 frequencies in the first column? That means in the second column, at the top, there will be the sum of the first and second, the third and fourth, the fourth and fifth, in the second column, there will be the sum of the first and second, third and fourth, fifth and sixth, and seventh and eighth frequencies. Okay, like that, in the third column, there will be now the second and third, the fourth and fifth, the sixth and seventh frequencies. And now, what about the remaining frequencies, like the first and eighth one in the third column? Aren't we gonna note down those too? Well, the honest answer is no. We will just leave them like that. Like this, we continuously put up the sums till we complete till the sixth column. Okay, and we select the highest values from each of the 6 columns, including the frequency one. Then we create an analysis table that has the name of the columns on the left and the x, or the values, on the top. Now we take the boxes, which are the x's from which each of the highest values are made. Like, remember, let's say in the first, when we add the first and second frequencies, right, in the second column, technically here I was not including the frequency column, right, but later on I included it. That was just for simplification, but if your mind can run along with this as a second column, so in the second column we added first and second frequencies, right? Now we in an analysis table, let's say in the first and second frequencies, when we added, the highest was 15, made from the 7th and 8th x's, okay, or the 7th and 8th values. So we will take 7th and 8th values corresponding with the first column name, okay, and the x, or the value with the most ticks, is the mode. Got it? It's pretty simple. Now, in the frequency distribution, the inspection method is detailed too. So we're gonna go here. Okay, so first things first, what is the mode? The mode is Z. So Z is the value of the mode. L1 is the lower limit of the class with the highest frequency, or the modal class. F1 is the frequency of the modal class. F0 is the frequency of the class before the modal class. F2 is the frequency of the class after the modal class, and I is the size of the modal class. Okay, you can add interval over here. So I is the size of the modal class interval. Now that we've got that part, we can apply each of these things onto the formula and solve it one by one. Now don't get confused, because I'm just making separation things just to know what is separate from the others. Yeah, that's pretty much. This entire thing, and this is technically a long one, okay? So we've got that part. Now we've understood how to do the inspection method of frequency distribution. We will always consider the one with the highest frequency as the mode, but in a frequency distribution, you will need to make a few edits, okay? Now, once we've understood this, what we need to do is the grouping method of frequency distribution. Now, here we create two tables, and the same thing goes on and goes on. Now, the one with the highest ticks is the modal class, and we will use the same formula again. So technically, this entire part, okay, this entire part was the part before this, okay? If you can detect the highest frequency, or if it comes in your exam, but this is technically not for the exams, okay, people? So we've got to know how to calculate using grouping method too. We follow the entirely same basis, but what happens is that at the end, the box, like the one with the highest ticks, you know, the X with the highest ticks, is the modal class. Now that's a class, right? The class with the highest ticks is the modal class, and we will use the formula for calculating the mode. Now, if a cumulative frequency distribution is there, we convert it to a normal frequency distribution and solve it. If an unequal classes are there, there will via conversion to equal class intervals, and then we will solve it. If there's inclusive series, we convert it into an exclusive series and solve. If there's a mid-value series, we create class intervals and then solve. Now what about the graphical representation? In a histogram, the highest rectangle will join the top corners with the corners of adjacent borders, and the intersection point is the mode. Now the relation between mean, median, and mode is that the mode is equal to 3 times the median minus 2 times the mean of the same data. Okay, you once can try this on one kind of data and check it for yourself. Is this formula provable? Okay, is this formula provable? Okay, now we'll go. Oh, it's done. Well done. Keep learning, keep watching, and keep studying. You can guess how fun it was to learn all of it. It was not basically stress, it was just fun. So guess we're gonna end this session like that.
Phew, that was enough to tire me, and I'm pretty sure it must have tired you too. And I know your head might be spinning at the moment, but hold on a minute, because it'll all calm down if you listen to that part of the video again and again, focusing on each word that I'm speaking. Now, one last topic after which I'll wish my goodbye. So, what's the last topic? It's the frequency curves. Wait, frequency curves? From where did that come? Well, frequency curves, actually, I'm talking about this today because we're going to learn the positioning of the mean, median, and mode, which I have drawn on the frequency curves, which I'll show you over here. Okay, so first of all, the normal distribution or the symmetrical distribution. Symmetrical frequency curve often is like bell-shaped, and it's called so too for a reason. And now the mean, median, and mode are all equal. In the positively skewed curve, mean, median, mode have an entire series of order what happens is that the mean is greater than the median, which is greater than the mode in the positively skewed curve, and the opposite happens in the negatively skewed curve, as you can see above. Then what happens, there's the J-shaped curve, there is the inverse J-shaped curve, there is the U-shaped curve, and there is the bimodal and multimodal curve. But as you can see, the bimodal curve can be symmetrical, or else, fair warning. Now, or else, what happens is that it depends on the graph. And the same is with the multimodal graph. So, thanks for watching today, and do not forget to like, share, and subscribe this video, and subscribe my channel. Actually, you can't subscribe a video, right? So don't forget to like this video, share this video and this channel, and subscribe my channel. Thanks and goodbye. Keep learning, keep going, and keep staying fit.